Hey, TC. Morning. Great. Is Lewis online? He's actually online? Let me see. You're kidding me. He is too. Ah, he's unboxing. Let's see. I can always come back. We can do this later. I haven't seen Lewis in a while. Yeah, I think given that we haven't seen Lewis in a while, I think I'll probably stop this stream and go and give him strife. Because I can't imagine his stream's going to go for too long. But then again, I've got to get this repaired. I'll stick around. I've got to get this. Got to get this done. Well, what I have here is what does it say? Let's say my wife, when she's doing her writing and whatnot, she often wants a timer, like an egg timer type thing, for just to alert her after 15 minutes or something like that to go off. But the trouble is, mechanical egg timers have a tick 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 sound which distracts her. And then for your normal digital timers, your ones that you buy from the shop for timing eggs and things like that, they've got too many awkward little interfaces and things like that. You got multiple button presses and things like that. And if a few of you follow my comments, you'll notice I'm not really a great fan of buttons on a lot of devices. So I've done this sort of thing before, but I thought I'd make it a bit more simple. Let's see, I'll switch panels. There we go. Alright. So I've just made up a little board, and it's going to use a 3-segment, not 3-segment, 3-digit 7-segment display, and a teeny tiny little buzzer. And it's only going to have two things. You're going to have a dial to set your time and a button to start and stop, and that's it. So, and it won't make any noises, or at least I can program it however I want. And I'll give it a shot. Now this is the first prototype. Whoops, I'm throwing it around already. Already I've made a couple of mistakes. The first biggie was that I got my battery holder backwards. And so when I attach it to the board, like so, I got the dimensions right. Unfortunately, the ground side is where I've got the positive. I've got the terminals the wrong way around. So I'll have to change that. That's my fault. But we can sort of get around that for now. I suppose I could... No, I can't pull those rivets out. Anyway, we'll leave that off for now. We'll just do it through DC power supply testing. Anyway, so we'll just get to building this. It's a fairly simple build. It's just using a little AT Mega. In fact, I can probably do it with an AT Tiny 48. Just find my chip. There you go. Whoops. For some reason, my microcontrollers are a little bit deep in the stack. I got all of maybe 2 hours sleep last night. Let's see, 88. Tiny 10, what are you? Tiny 48. Maybe I'll do, maybe while I'm prototyping, doing all the firmware, I'll do it as an 88. What are you guys? Oh, you're tiny 25s. Okay, here we go. That's my last 88. I have to stock up on some more. Alex, I saw that you'd streamed on, what do you call it, on Facebook. Didn't realise you could. Hey, PB Henry. I don't. I'll put the hot air on anyway. The soldering iron on. I use these megas for so many things. It's sort of like a universal chip for me. So you'll have to excuse me if I'm a little bit ragged. Just I can't sleep lately. I'll do. Put my extractor on. These chips are a little bit old. I can tell by the pins have got a little bit of corrosion on them, making it a little bit harder to solder on them. It's not bad, but you wouldn't want to put them in an oven to do a reflow. PB, yeah, this is done in Eagle PCB. It's pretty rough. We're gonna have to use hot air on this one. Don't know why that one's so big. Yeah, Mike, I got about 2 or 3 hours of sleep and that was about it. It's not really good. Not good at all, actually. So what's the audio like with the air filter running? I do have plans to make it quieter, but I could save that for another day. Hey Motorman, it's not that bad at all. Okay, that's good. It's pretty loud here, but it seems to get cancelled out somehow. Just trying to find a suitable resistor. That's the one I want. The muffler that I want to get for this, it's about $100, $110, $120. It's just a big fat carbon canister. It doesn't. Its purpose isn't to be a muffler, but it will have the same effect. It'll just take the edge off the audio. The wind noise, because that's pretty much what it is. It's just wind noise. Yeah, well, I don't know if it is active noise reduction because, what was I say, it's just a straight microphone, so I don't think it's got noise reduction, so I don't know what's happening there. These are 0603. Why is Lewis asking my help for a microscope? He knows how to put those things together. I'll let him work it out. Yeah, the resistors are 0603, so they're perfectly... You can easily do this without a microscope. I'm only using a microscope because it's easier. Now the way this whole board works is, well, as you know, it's a 3-digit 7-segment. And with this particular unit, to reduce the number of pins on it, what was I say? All the digits have a common cathode on them. So, but they all share the same anode pins for each particular segment. So you have to go through and switch on the segments that you want for all three ideally. So when you scan out the digit, you're not trying to set all the digit bits per digit. What you want to do is you just find out what segments are common and run it for all three. Anyway, I'll show you in the software when I do the next stage. Hey, hummed it. And my hair is again getting in my face. I really need this haircut. Big time. Anyway, the technique is similar to what they use on most clocks and things like that. You'll notice if you shake your head when looking at a clock, it just sort of turns into gibberish type digit representations, and that's because of the way they do the segment scanning, or illumination rather. That was naughty, I shouldn't have done that. It's way too much solder there. Yeah. You guys can share. I forgot to get that one. And when you're driving the LEDs, you want to try and drive them as quick as you can. Because you are cycling through the segments, you don't... let's see. In order to get a reasonable amount of perceived brightness, you want to keep their duty cycle up pretty good. We need a diode now. Yeah, because if you don't get the duty cycle up pretty good, then you have to drive the LEDs too hard so that the perceived brightness is high, and that just burns them out. You're a monstrosity. Yeah. Yeah, you're an overkill. Let's find something a little more realistic. Yeah, not a fan of you guys. What about you? You're too small. Brilliant. Too big. Ah. Hey Paul, hey Ashes. Yeah, I'm really happy with the way the J tip works on these situations. It allows me to get around that corner, which is nice. Oh. You're a little bit bigger than I thought. Oh well, that's not a biggie. These buzzers are the ones that I bought, well, I thought I was ordering the right ones, and then China sent me the wrong ones, and now I've got a whopping great big reel of them that I've basically got no use. I've got enough buzzers to last me for the rest of my life, basically. I need to get out of this corner here. I should have made the pads a bit bigger. Might have to actually hot air that. Yeah, Firephone, it's actually, I suppose, technically my first stream for today. At least in terms of daylight hours. Because I did the other one last night around midnight. What's going on here? Probably should be using a much bigger tip for this actually. There's some nice cold looking joins there. I do. It's just a prototype. Firephone, you're talking about the ones where they've used plastic welded nipples. I hate those things. I tried a few times, I gave up, to be honest. Ended up just buying the whole units. What are you? You're a 10k pull up. What are you? R7. Ah. It's good. So I might put that in last. Let's see. I've got to find some headers. There they are, naturally at the bottom of the stack as well. Ow. Now the reason why I want headers is because the LCD display or the LED display is going to be sitting on top of all the electronics, and that makes it hard for me to do any prototyping if things go wrong. Alright, so I use these machine pin headers, and yeah, they should do the job nicely. The machine pin headers are rather expensive, so you don't use them too often. The other thing is, with machine pin headers, you can't use them with your normal square pins, your normal square pin headers, because these ones are round insert. So you try to jam a square pin header into there and you'll ruin it. Alright, now we just need our trim pot, well not trim pot, our pot. I think they're in the other room. Yeah, man, you can do that with the .1 headers, although I generally don't. Looks like I'm going to have to get a smaller resistor pot. This one's huge. Alright, I think it's pretty much done. So what I'll have to do now is start writing up the firmware for it. So looks a little ugly at the moment, but what I'll probably do is put that into a sort of a little perspex case, acrylic, whatever you want to call it. Just sort of a sandwich type thing where you've got perspex on the bottom and acrylic on. Let's see if this. It's just a shame that I botched this up in terms of the polarity. There we go. So ideally what will happen is it'll just go to sleep or stay asleep. You press the button and it will make an indication that it's alive. And then you set your timer. I'll probably say anything between 1 minute and 60 minutes on the dial. And then when you're ready to start your countdown, you just hold it down for a second or so and I'll make it chime so it sort of confirms, and then it will I'll probably make it so it goes blank, or maybe just run these decimal points every couple of seconds or so just to indicate that it is alive and counting down. The main thing is you want it to be, in the case that I'm trying to do here, I want it to be as non-distracting as possible but easy to use. So hopefully this will do the task. I'll be doing the firmware development later. What's the time now? 10 o'clock. I'm going to have to start preparing for customers to arrive soon. And I've got another job I need to fix up over here with the computers. But yeah, maybe tonight I'll get around to the firmware and I might be able to live stream that on the workstation. So, does it work? Yeah, unfortunately I'm not going to be able to really show you much because there's no indicator lights or anything at this point. Like, I'll need the firmware to be up and running in order to show anything at all. But the circuit board itself will have to be respun because of the reverse polarity on the battery pack, and I may have to see if I can find a smaller pot, but then again maybe it'll be fine. But the biggest concern is that this reverse polarity, that was a real stuff up, real stupid of me. The unfortunate thing is sometimes when you build your own Eagle library parts, you sometimes get your orientations backwards. So, which means now I'm going to have a pack of 9 other boards that they'll just go into my archives. And you never know. Sometimes when you make a board reasonably generic, you can come back and use it for other things. So we're going to leave it at that. It's time for me to get on with my normal business working day. This was a personal project, and like I said, maybe tonight we'll come along and do some firmware development. It'll be in the other room, and hopefully we'll get a working timer, at least for now. So well, I don't know if Lewis is still streaming or not. I'd imagine he's finished by now, but if he is, I'll go jump over there. But anyway, thank you everyone for dropping in, and I'll catch you next time.